let's see, what day is it? I think it's around November 13th, November 14th. We're getting ready for the high hover with serial number 1, and we did the dry run yesterday, and everything looked beautiful. Also, the weather forecast for tomorrow is perfect, but at the last tail end of the dry run, we noticed that this node called Drum Sensors A was glitching out. And so this morning, Johnny and Scott and crew, in conjunction with the power team, did a whole bunch of high pot testing, which is where we have a little gizmo called the Megger, which applies high voltage and measures the resistance. And I think the problem was pretty localized to the drum slip ring, which is what lets a bunch of Ethernet and power and stuff go in into the drum, which is turning, so it has to have a bearing that can turn and carry the electrical signals. So somehow, while voltage is up, it's glitching. This affects the encoders that tell us which way the tether is pointed out of the ground station once it's in high tension mode. So our conundrum, our problem today is, do we start fixing that, or do we accomplish as much of the test objectives as we can tomorrow? Yeah, the issues are that, the fix is very invasive, and we don't have the part, and we don't really know what's wrong with the one that we have installed. The thought is to maybe steal one from GSO202. Yeah, the consequences for flight are, assuming there's no additional failures, which is an assumption, we can do the full payout and do the transform, and then after the transform at that point the sensor that we use to see which way the tether is pointed may be unreliable. So the plan is that we'll fly to that point and then, look at the data and see if it's died by then, and if it's still working, we'll do it. Even if we don't even get to the transform, it would be very exciting to do the high hover. This would be the first time we have done payout and reel in with the full M600, because during RPX, of course, we just had the whole tether lying on the ground to start. So that operation is very interesting and exciting, and also we've been working very hard over the last couple weeks to for this feature that controls the angle at which the tether leaves the ground station as it's being paid out. So all of that would be tested, and I think that would be quite valuable. Yeah, so there's the payout and the reel in, there's the transform, and then there's the post-transform. Those are the 3 phases we're trying to test. Our ground station, the big scary robot, it has sort of 2 main phases. The first is called reel, like reel in or reel out, which is where the drum is spinning and the tether is coming out, and that's what it does in that phase. But when the tether is coming off of the drum, it can't support the huge tensions, up to 20 tons that are seen in crosswind. So what we do is, after we're done reeling out the tether, the top of the ground station kind of rotates such that then the tether is anchored to the ground side gimbal, the GSG, and that's what can support the crosswind tensions. So this like a carefully choreographed maneuver, which part of the ground station rotates by 90 degrees, and the tether has to swing through a certain region of it. So we're very interested in proving that can be done reliably. The kite has to be held at a particular altitude so the tether is at the right angle, such that the perch can pass over the tether and things like that.